Hi guys, it's Inventor Andy, and today we're going to be looking at using the asynchronous UART drivers for serial communication on the Atmel D21 Xplained Pro board. So the difference between last week's tutorial, where we looked at the stdio functions, and the asynchronous functions this week, is by using the asynchronous functions, what we do is we trigger an interrupt every time data is sent or received on the serial terminal. So rather than doing things procedurally like we did with printf and scanf, where we write, then we read, or then we read and then we write, and it's a series of steps. What this method does is it allows you to listen for data coming in or going out, trigger an interrupt which breaks the main programming loop, and handle that input or output before returning to the main programming loop. This is useful for applications where you don't necessarily know when the input or output on the serial line is going to be, so you need to listen out for it and handle it when it does happen rather than waiting specifically for it. So if you open your browser and go to start.atmel.com, and we're going to click on Create New Project. Make sure Show Only Boards is selected and scroll down and find the D21 Xplained Pro board. Select this and click Create New Project. Okay, first things first, let's rename it. Let's call this Async UART. Okay, next we're going to add a software component, and if we go to drivers, and we want to scroll down until we can find the USART driver, which is the Universal Synchronous Asynchronous Receive and Transmitter. So click Add, and wait for that to be pulled in. Okay, so we're going to rename this to Serial, and under the driver we want to find HAL driver USART async. Make sure the transmit and receive buffers are enabled and set the baud rate to 19200. Next up, we want to find the pins that we're going to use to send and receive the data. So we want to do this on the virtual COM port to save us from messing around with wiring up an FTDI cable with the board. So if we go to pin marks, stretch out that header field to make it easier to read, and we're looking for the virtual COM port. Okay, so pin 43 and 44 are the virtual COM ports, and we can see TX is on PA22 and RX is on PA23. Let's go back to dashboard, set the TX to PA22, set the RX to PA23, as you can see now it's been highlighted. Okay, so we're all set up. Let's go ahead and export the project. Make sure that Atmel Studio is selected. Let's call this 03 Async UART and click Download Pack. Save that somewhere you'll remember. Okay, so once that's downloaded, go ahead and open it, and that should open up Atmel Studio with the Create Project wizard. Create your project and save it to somewhere you'll remember. Click OK. Okay, so we're going to be working in the main.c file, so open that. And what we're also going to be doing is looking at some of the examples that Atmel provide with their drivers. So if we open the examples folder and click driver examples, and I'm just going to drag this across so that we can have it side by side with the main screen. Makes it a little bit easier to read. So there you can see we've got the asynchronous serial example functions written out. Okay, so first off we're going to create some flags for our serial data. So these are for receiving and complete receive. So serial receiving equals 0. So these flags will tell the application when it's receiving data and when that data has been completed. So next up we're going to create some counters. So this is a counter that we use to keep track every time we receive a byte, and then when the transmission's completed we store the total number of bytes. Now let's define the size of our receive buffer. This is the number of bytes that we can receive over serial before we get a buffer overflow and we have to start again from 0. So let's call this serial buffer size, and let's set that to 200. Now let's create our receive buffers and our transmit buffers. Now, you'll notice that our transmit buffer size is going to be slightly larger than our receive buffer size. And that's because we're going to add a little bit of an extra message at the beginning of it. So if you count the number of characters in this string, it's 14 characters. So the transmit buffer, we're going to transmit everything we receive plus these extra 14 characters. Now, just quickly, we're also going to set our initial receive buffer to 0 bytes. That's to make sure we don't have anything left over in memory. Save this, make sure we don't lose it if anything unexpectedly crashes. Okay, so next we're going to create our callback function for receiving data. Now if we look at our example functions, our callback functions here take these parameters. So if we just copy that over, so first let's create a counter and a single byte for storing the character that's received. So ch is the character that we're receiving over the serial line, and count is the number of bytes we received in one chunk. Next up, we're going to read a character in, So count, which is the number of bytes we've currently read in, is equal to IO read and we're going to use the serial input-output structure, and we're going to use the IO within that. We're going to read that into the character that we just created here, and we're going to read 1 byte. So we're reading this in a character at a time, and that's because this function gets triggered every time a single byte is sent over the RX line. So now we've received the character, we need to do something with it, and that all depends on whether we've just started reading, whether we're halfway through reading a string of data. So let's check if we're already receiving. So remember, we created these flags up here, serial receiving and serial complete. So if serial receiving is 0, this means that we haven't started receiving yet, and this is the first byte of a new string. So first, let's check that we haven't got any new lines or carriage returns. This just prevents any leftover data from the last input string being treated as a new string. So there we go. Assuming these aren't carriage returns or new lines, let's set the receiving flag. So now we've changed that flag, and it means that the next byte we receive, it won't go through this section. Now, because we're starting new data, we want to reset the byte counter. To 0, and we're going to start filling our receive buffer. So we're copying the character that was read in into our RX buffer at the position of the current counter, which should be 0 in this case. Now, the final thing to do is we're going to increment our byte counter. We're going to increment that by count, which is the number of bytes to be read in. It should be 1, but this is a robust way to make sure it is. Okay, so now we've dealt with the first character in a new string, let's carry on with the rest. So create an else condition. Now we're going to continue filling the buffer. We're going to increment the counter. And now we're going to check for a new line or carriage return. Now in this instance, one of those characters is going to signify the end of the message. So once we're already receiving, we want to check to see if we've got that terminating character. So ch equals, and we want to check either of them, not both of them. So if we've got a terminating character, we're going to set the completion flag that we created earlier. And we're going to set our total bytes received. And what we're going to do is we're actually going to set this to the total bytes received minus 2. So we expect the terminating string to be either a /r or /m, which are 2 characters. So we subtract those from the end to make sure that we're not including those. And our final check is to check for a buffer overflow. And if that's the case, what we're going to do is we're going to write over from the beginning. So this handles, if we've just got more than 200 bytes in our receive buffer, we start overwriting from the beginning until we get that null character. If it's greater than or equal to the serial buffer size, reset the counter. Okay, so next up we're going to create a blank function for transmit. We're not actually going to do anything in this instance. So static void serial txcb. And we're copying our input parameters. And I'll just put do nothing in here for now. Now, you may be wondering why I have a callback function for transmit. In some applications, you might want to set a flag or set some parameters when you've sent the transmit. So, for example, if you're polling a sensor or a device for data over the serial line, you may want to set the flag when that poll happened so that you can create some conditions later on in the program based on whether the sensor was polled. But for now, as I said, we'll just leave that blank. So now on to our main function. We're going to initialize our serial port drivers. So let's register our callbacks. And you can see what we've got here. That's how we register them. So we're going to register it to the serial. And this is going to be our transmit callback. And we're going to reference our serial txcb function. Make sure to get rid of those brackets at the end. Now let's register our receive callback. Again to serial USART async rxc callback, not tx. And again, get rid of those brackets at the end. Now let's enable UART on those ports. Okay, so we've initialized our USART on those ports and we've set our callback functions. Now if we go into our main application loop, what we're going to do is we're going to wait till we've received and wait till that receive is complete. So first let's check if we're receiving. And once we know we're receiving, let's check if we've completed. Okay, so let's go ahead and reset our flags. And then we're going to copy what we've received into the transmit buffer. So if you remember early on, we define the transmit buffer with this little string of characters at the beginning. So there's 14 characters there. So we're going to copy from the 14th character onwards. So mem copy. But we're going to copy from the first character of the receive buffer because we want all of the receive data to be sent through. And we want to copy the entire buffer, so we use the serial buffer size define. Now we're going to print this message to the console. So, if you can see in our example functions, we've got the IO write function for sending data out. So we go IO write. We want to use the serial.io communications descriptor. And we want to write the what's in the TX buffer. And we want to write the total bytes we want that plus 16 bytes. So that's the 14 we've got at the beginning plus the /r and /n at the end. Now our final step is to clear our memory in the RX buffer so that it doesn't appear again when we send the next message. So clear memory and set. We want that on the RX buffer. We want to set that to 0x00, which is a null byte, and we want to do it for the entire buffer size. So we're done with the driver examples. Let's close this. Now, as you can see, I've already plugged in the Xplained Pro board here. And if you go to the data visualizer, you can see the virtual COM port is listed. Make sure our baud rate is set to 200. And we're going to click Connect. Make sure that our embedded debugger is selected as the programmer. And now let's go ahead and run this application. Okay, so if we go back to our data visualizer and let's type our first message. Make sure /r and /n are added to the end. And there we see your message, hello world, which is what we typed in. Let's try another message, shall we? So we're receiving on the virtual COM port and we're printing out what we've received plus a little bit of an extra message. So there we have it. That's how we use the asynchronous drivers and the interrupts to communicate with serial devices. Thanks for watching, guys. Hi guys, it's Inventor Andy here. Thank you for watching my video. If you liked the video, please click like, please subscribe to my channel, and please feel free to add any comments if you've got any suggestions for tutorials or videos that I can do. Thanks very much, guys.